Good afternoon to all of our delegates and our speakers for this afternoon's session. I'm Richard Jones and I work for the Railway Industry Association, or RIA, as we'll refer to it this afternoon, and I'm pleased to welcome you to this week's series of webinars on the Digital Railway Programme, arguably the most significant engineering programme in the industry over the next 20 years because it signals a complete change in our industry. It's important to say here that RIA is not the sole contributor to these events. They're organised completely in conjunction with Network Rail and with the UK Rail Research and Innovation Network, UKRIN, and they're supported by Network Rail, for which we're very grateful. And of course, I want to thank all of our speakers this afternoon, without whom none of this would be possible. So let's just have a recap over what we're covering this week in our sequence of 5 digital railway events. Yesterday, we heard about an overview of the project, led really by Network Rail and London North Eastern Railway, LNER. Today, we're going to be looking at the first rollout projects, a really important area, I think. Tomorrow, we're going to look ahead into the longer term, covering issues like pacing the work at a rate which the industry can deliver and developing the skills we need as an industry to deliver this programme. Thursday is a day where we focus on innovation, pretty much stuff that's already happening, actually, and also R&D, which will feed into later innovation. That's a really exciting day, and I think we've got some great content then. Friday is about supply chain building and the opportunities for SME in the programme. Now, this is an Unlocking Innovation event too, and innovation is vital to delivering the programme. So each day we'll be hearing from people who are innovating and people who are supporting that innovation as well. So for today then, Digital Railway is finally underway, and we'll be hearing more about this first wave of projects from Tufik Mashnuk of Network Rail about East Coast Main Line South, from Ewan Spencer of Siemens about cab fitment, Mandy Stringer of Siemens about the command, control and signalling work going on. And then that'll be backed up with our SMEs, who today are both fairly new to the rail industry, but they're doing really exciting things with gathering and processing data. So this is a look into a digital future that's actually becoming a reality now. It's not just a dream anymore. So on to our first speaker. Tufik Mashnuk is Programme Director at Network Rail, the East Coast Digital Programme, and there's no one better to give us an overview. So Tufik, can I ask you to bring your camera up, please, and join us? You've got your first slide there. So Tufik Mashnuk.
Right, hello everyone. It's really good to be able to speak to you and update you on what's going on with the program. I've spoken at this event for the last 2 or 3 years now, so anyone who's attended this has really followed the journey from the early opportunity statement that we had for East Coast Main Line and how we've evolved that now into a live, real program that will hopefully change how we do things on the railway. So as I do that, we're just going to start with a short film, and then I will take it from there.
This is the East Coast Main Line, one of the UK's vital economic arteries. A third of our population live within 20 miles of a station on this line, and every day, people and businesses from north to south rely on it. We've got new and improved trains coming in, and we're adding many more services than we have now, which is great news. But that's a lot of pressure on a very busy line like this.
The main challenge is it was built in Victorian times, and one feature hasn't changed all that much: the trackside signalling.
As you know, trains travel along the same piece of track at high speeds and take a long distance to stop. To keep them apart, we divide the track into fixed sections called signal blocks. The trackside signals tell drivers how far they are from the next train, so they know how fast to go to be able to stop. This system is how we've been keeping trains a safe distance apart for over 100 years. The trouble is, the way the railway is operated is limited by the size of these blocks. And on a mixed-use railway like this, they're fixed for the worst-case scenario. The system can't tell one train from another, and the trains are only told what to do at these fixed signals. This limitation stops the railway from performing at its full potential and results in thousands of hours in delays for passengers every year. But there is a known solution. It lies in digital technology, already used in Europe and being deployed across the world as the global standard. The European Train Control System, or ETCS, is transforming the way railways are managed. It works by replacing the old trackside signalling with in-cab train control and traffic management. This system recognises the different types of trains. Both track and train can talk to each other continuously, so they make best use of the tracks available and can respond in real time. This creates a more dynamic railway, one that is more responsive, more resilient, and recovers quicker when things don't go to plan. And most crucially, because train speed is continually supervised by the system, the railway is safer. These are the building blocks of a modern, high-performing, right-time railway. The result is a step change in the way trains are operated and how passengers and users experience the railway. But can we afford this digital upgrade to track and train? The real question should be, can we afford not to? The bottom line is, the old signalling needs to be renewed anyway, and in the long term, ETCS will be cheaper than continually patching up what we have. As for these, 70% of passenger trains on East Coast South are already fitted with ETCS, and many of these travel the whole line. So we've got digitally enabled trains, but without digitally enabled signalling. You want to get the full benefit. Now, because this is about both track and train, we need a fundamentally different approach to make it happen. One that brings our industry closer together. It means everyone working in partnership. Operators, Network Rail, government and technology providers for the benefit of passengers and users. And that is in our hands. Because the East Coast Main Line is a railway with enormous potential. It's time to unlock it. For everyone who uses it and for the communities it serves. The opportunity is here. The time is now.
Right, that film really summarizes what this program is about, and we made it to try and simplify how we make the case for what we're trying to do, because to the broader world, to stakeholders, to funders who need to make decisions across a number of priorities, understanding how railway signaling works, understanding that it's the benefits it will achieve, and understanding how you go about making such a change to the railway is fundamentally crucial. Even within this industry, people find it enough to understand some of the elements of this, so trying to explain that to the outside world is even more challenging. So what is it we're trying to do? Fundamentally, we are looking to change the way the railway operates, and the way we've crystallized that message is in delivering an East Coast railway that works better for people. It's quite generic, but it points very directly to the fact that the train control system and how we run the railway is there a better railway for people, whether it's passengers or customers. There are people that depend on that railway in society and in the broader economy. The way we're about doing that is based on 4 core principles, which we've enshrined in the mission of the program, which is transforming the East Coast Railway through digital train control technology. So transition in partnership to passengers and users. Working in partnerships fundamental, and I'll emphasize elements of as we go along to deliver sustained benefits. Fundamental attributes of this program is that we are absolutely clear it is about changing how we run the railway. It's not just about the technology and installing equipment. That the only way to do it is through a deep partnership, because it is immensely complex and involves so many parties that need to come together. And it is there to enable and deliver benefits. And therefore, the setup of the whole program needs to be geared up. The objectives are highlighted there, which lead into the benefits that are defined within our whole program approach and how we go about doing that. In the broader ecosystem of the program as well, there are a whole bunch of associated strategic objectives. The program is delivering the first industry partnership. It is the first time that we have a supplier embedded in the program the way we have. So it's a new procurement and supplier partnership model with a whole life cost and a whole life relationship approach. It enables a long-term deployment plan. It is a change program. We're organizing how do you do things like this in the railway as a change program, organized as a change program, delivered as a change program, which doesn't happen. Big capital enterprises like this are delivered as capital delivery projects. They're focused on delivery of the stuff, and the change is left for the operational and user organizations to figure out. But for this program, it is fundamental to what we are doing and at the heart of what we are doing. So how do you go about doing something like this? And I just want to touch on that a little bit before I go into where we are and some of the big recent events and what's ahead and the challenges. I use this image from the 50s of when Sweden changed its driving orientation. And it's just a simple way to really think about when you go about complex change, like, well, in some ways very simple. You're changing from one way of driving to another, but how you go about changing human habits, i.e. the way we operate, and do it in a way that can be made progressive is immensely difficult. Engineering a car to go from being left-driven to right-hand driven to left-hand driven is not difficult. It is immensely difficult. And that's a similar kind of conceptual challenge that we face on East Coast Digital. So the first of those things that we had to really understand is recognize who's involved in this program and the fact that it is immensely multi-organizational. There is no way of delivering this without bringing many organizations together. As a bare minimum, we have 4 train operators, a Network Rail route, 7 freight operators, and a number of heritage and charter operators. Each one of those needs run on sprint, not to count the fact that it affects how you access the railway for many suppliers. So the first thing is a recognition that it's multi-organizational, and therefore how you organize the program needs to be able to cut across those organizations to create a governance framework and a bond across those organizations, not just to be vested in this, not just to participate, but to then go through that change. If one of those operating entities do not go through that change, we don't have the ability to run that railway that way. So we thought very, very carefully about what lessons we can learn in implementing this. We looked at Thameslink and learned about the fundamentality of integration and how we do that. We looked at the Banedenmark project and understood that you must get the trains fitted early and you must start the change journey early. When I visited the Cambrian line in Wales, what tends to happen, lots of people look at kit, they look at the train, they look at the driver machine interface on the train, they go to the signaling center. My big takeaway was talking to the signaler, the driver, the train technician, and the signaling technician, and all the pains that they felt living and trying to run a railway with the system. So that made it absolutely clear that those are the people we're delivering the system for, so that they can run a better railway. So they are a fundamental part of how we go about designing the solution in its application, how we implement it, the change we have to introduce, what procedures you have to layer in to deliver that. We learned from the Dutch program the challenges with the first-in-class and fitment of complex trains. And we learned from looking at things like the National Air Traffic Service, NATS, just how you can do things differently with suppliers and the role they can play in a user-based, user-oriented, people-centric design application process, which is not very common, or actually it's very uncommon in industrial engineering. So we've crystallized this into the program through what we call critical success factors. I won't go through them all now in detail, but they're shown on your screen, of which there are 6. And this is the lens by which we live and breathe this program, by which we set its objectives, we organize what we do. And very briefly, things like user-led, we are constantly looking at what are we doing to make sure that the program is oriented and is doing things that makes sure that we understand what how the user is going to use this. Are we running the right simulations? Do we have the right workshops? Do we capture the requirements in the right way? And so on and so forth. Change enabled is probably the biggest challenge we face because we rely on other organizations needing to go through that change. And then we are having to, so therefore we have lots of actions and activities around that critical success factor to make sure we are enabling that in terms of who's appointed as change managers, how vested are those businesses in the change, do we understand the impact on the business, how are their plans embedded, is it all adequately funded and commercialized if required, and so on and so forth. Technology and industry partnership I've spoken about a lot, and it's fundamental given the nature of this. The technology aspect is crucial in that the supplier is central to the design and how we go about implementing this and bridging that gap between the operator and the user and the technologist. Integration is so crucial, we've said it 3 times, and that was a big lesson from big projects like Thameslink, and being a learning program that's constantly learning from its own experiences and others, and we've embedded that in the way we do things. And that is then crystallized in a MSP framework for the program, managing successful programs. This is unique for major capital investments on the railway. It is such that the way we organize this investment on behalf of government, the way we organize the delivery and the integration of many disparate projects across many organizations, and the way we organize change delivery within the operating organizations is all on a par. And what usually happens for big capital projects is you have the big capital delivery, the investment's done by a client somewhere else, trying to stitch it together, and the change is left for the operating organizations to figure out. So that's the fundamental part of what MSP means to this program, how we do that. The program is delivered in tranches. This is how the benefits are materialized. So tranche 1 is delivering the Northern City Line, the Moorgate branch. Tranche 2 is that first footprint on East Coast South that enables all the training, all the business change to happen such that you no longer require the signals on this footprint. This is our K2, our Everest. This is the peak that we have to climb, after which things get immensely easier. This is the first thing that brings everything together. And once we've done that, the progressive rollout, which is tranche 4 and tranche 5 optimization, is infinitely easier, a lot less integration, a lot less change. And tranche 2 in the middle is about deploying traffic management, which makes it easier to run that railway throughout. So I just have a slight delay with the slides. So over the last few months, so in the mobilization of this program, the last 2.5 years, went from an opportunity statement to a business case to developing the plans to secure investment and funding. And the last few months has seen what I call kind of 3 small steps for the program and a giant leap for the industry, which is first the fact that the government has now approved the business case and approved funding. And what that means, approving the business case, means the government has approved that East Coast Main Line will transition, or East Coast Main Line South at least will transition to a no signals railway. And that is a huge deal. It's the first intercity railway in the UK to do that, and also unlocks one of the core funding required to enable that option. Because if it wasn't going to migrate to a no signals railway, you may have not needed, for example, to fit all the freight or all the on-track machines. That option, that confirmation of that option, unlocked those other projects. And with that came the funding to complete all train fitment from the lessons that we've learned, and to commence the operational readiness activities that allows us to trigger network change, bring all the operating businesses together into a change program from now, because it takes time to understand the impact. It's the most scope, is understanding how is this business going to change, what areas need to change for the future, starting to recruit, starting to change procedures to simulate those and implement those. So that's been the fundamental part of starting that journey. And the third is to complete the migration planning that will crystallize the plan for the infrastructure, which completes the funding in the full business case late next year. So that announcement was really important to us. It was going to happen literally as the COVID lockdown hit, so it got delayed to an appropriate time, and it came out last week. The second is that we've awarded all our partnership contracts, which is really, really important to us. They are crucial to how we are going about delivering this, both in our train control partner, traffic management partner, and in our railway system integration partner, which is helping us organize this. And the third is we've started the network change process, and that makes it very real for the industry. So all these together have made this program very real. The case is approved, the migration strategy is approved, the funding is secured for the things that we said we must start now from the lessons that we've learned. The partners are on board, and we've started the network that brings together way to bring change. There's just a slight lag on the switch, so that will show up. So looking ahead, what should show up in a moment? It's gone too far. Yes. So this is what, looking ahead, I call this our Tesla Roadster moment. So any car enthusiasts might think that's a Lotus Elise, but it's the original Tesla Roadster where they took a Lotus and converted it, which was a very painful exercise, into electric car. And what that did, they did that to show that an electric car is really compelling, because at that point, electric cars were these really slow, horrible things you had to charge every 3 minutes. And when this came out, people were shocked at how fast it was. Obviously, the battery technology wasn't great, and so on. So when I look ahead now, so we've made the case for the program, we've got the government and industry behind, we've put the foundations of the program, the investments there, which is immense, and considering all the other priorities that government has. And we've triggered the change process, and we have the partners on board. So looking forward, the things that we need to now bring together are all centered around building the credibility and showing people what this is. So up until now, we've been telling people, we've been describing how you'd go about it. We've been thinking hard about how you'd organize it and what you would do. And the next phase is all about being absolutely able to point and show people this is what it is. So for us, what that looks like over the next year to 18 months is, in the middle of the screen, starting to deliver the Northern City Line, which is our first Pathfinder project, is absolutely crucial to do that. It's a urgent asset renewal, so we've started that process. We're designing the change activities with GTR that operate there, and we've developed a migration strategy for that, which is the foundations for what we do on East Coast South, which is a brilliant way of going about this, to have progressive operational migration throughout. We're also starting to develop the migration plan for East Coast South, which is where is that first footprint going to be, which is a trade-off and a balance between how quickly can we deliver something and what is operationally beneficial to do the business change and the migration planning, and that's happening now. The graphics at the bottom left show all the performance modeling and operational business change modeling that we're doing in understanding how we're going to go about this change, all the operational readiness that we're doing with all the industry partners. We're going through the network change process that formalizes everybody's engagement, shown in the arrows at the top. We are commencing the traffic management activities now, which is doing a design proposal for implementing traffic management in York Rock. We also have that for Derby in the Eastern region. And crucially, fitting all trains. So even though there's a lot of planning activity, design activity, the program now sits on top of and oversees the fitment of all the trains that are required to deliver this solution on East Coast South. So in the last minute or two, I just want to highlight some of the key challenges ahead. So this is, as you know, my fascination in what SpaceX are doing with those who've heard me speak before, with rockets, and the amazing thing of landing a rocket backwards, which seems so difficult to imagine until you see it. So you think about what kind of challenges do we face looking forward, and those are our headline challenges. The first is, this is so multi-organizational that having clear accountability around this program is tough. There's no way to do it. You cannot fold all these organizations into one. It is a huge multi-organizational enterprise. So we've created the structures and how you govern that, but it needs a huge amount of effort to keep all these businesses aligned together. And that is tough. And that is going to have some challenges and pitfalls in the coming months and years as we start to develop change plans and the different pace and readiness and abilities of different businesses to go through that change. Closely associated with that is business capability to respond to change. There is a bit of a fatigue of change in the railway. There's lots of things that are changing that need to change, and lots of priorities seeding this. So getting the businesses to have the capabilities to build the knowledge, both in terms of how they're going to change and what ETCS does for them, and to gear up for that is a very, very big challenge. Probably our centrally biggest challenge materially in delivering this is the ability of the various businesses to respond to that change. The third is about, we have a whole new way of delivering this with a train control partner. So really excited about that model. It is the approach for the future, I hope, but we have to make it work. And in making it work, the train control partner needs to step up into that role. We're having to play a different role in Network Rail. This is the first time, so we don't have deep memory of working this way. So we're having to find our feet very quickly to make it work, because we believe this model will be a lot better. Fourth is the fact that we have some incredibly complex legacy fleet to retrofit on track machines, figuring out how we make heritage trains work, and so on. So these are all very prototype-based engineering challenges that will have their setbacks. The fifth is really understanding the benefits from a timetable perspective, because we do not currently in the industry have the tools to do that. So we're having to create the tools from scratch. So everything we do so far, it doesn't adequately show the full extent of what ETCS will do. So it's important that we develop those both for the investment case at the full business year, and so that we can develop the timetable that will come on the back of that first footprint to unlock those benefits. And very lastly, and I will close with this, is to say the biggest challenge which we face now, that has been further reinforced by the COVID situation and coming out of it, is that of credibility and affordability. I cannot overstate to anyone who might be listening, who's associated with this program, who touches it somehow, who's close to it somehow, or is it distantly related to it somehow. The next year to 18 months is all about proving that this can be done. The plans are credible, they're deliverable, they're integrated, and they are affordable. Because the government now, as a result of COVID, is going to have a whole new range of fiscal challenges they did not have a few months ago. So the case for programs like these have to be incredibly clear to stand a chance at gaining the attention of government amongst all the other priorities that government's going to have for society and the economy. Okay, it was good to talk to you, and I look forward to some questions later.
Brilliant. Thank you very much, Tufik. And I don't know where you're sitting, but if you open the window, you can definitely hear the sound of cheering from our audience, because I think what you've given us there is a compendium of wisdom. Your advice about taking this opportunity to impress the government with what we can do in a rail project, as compared to what we usually do in a rail project, that is so important. You know, there's so much competition, not least of all from other transport modes as well for investment. We've absolutely got to show that we're delivering value. This is a great opportunity, and I'm so delighted to see that you've got a good grasp on it. A couple of things. We had some problems there with sound, and also missing, not everybody was able to see the video, which is absolutely excellent, by the way. There's a link in your chat messages, everyone, and also in questions, to take you to YouTube where you can see the video. And if you felt you really missed anything from the presentation as a delegate, please let us know in questions or chat, and we'll take a look at that on balance. And if too many people missed valuable content there, we'll re-record this talk with Tufik at a later time and make it available. So later on during the week, when hopefully Tufik's area doesn't have bandwidth problems. Okay, so thanks everyone for your patience with that. Just to remind you that you can ask questions in text by using the questions dialog box. You should have up in the corner of your screen a grey box. One of the tabs in there is questions. Click on that and you should be able to make a written question, which we'll pull together, and we'll have a Q&A session right at the end where all the speakers together, we can look at the questions as a whole. We can get the speakers as a panel to deal with them. Also in there, you've got a handouts tab. So you've got all today's presentations as a single PDF, and you've actually got all yesterday's as well, and those will mount up during the week. So you can actually pull down all the presentations in a concise format on PDF. So I think you were very clear there about the objectives of the program and the benefits that your team, your wider team, is setting out to deliver. Of course, you're absolutely right, this depends on the supply chain. And a key part of that is the equipment on the train. It's by no means a simple job, and it's often overlooked because it's not necessarily a part of a traditional signalling fitment. And also, if you wanted to pick a problem child within the whole area of rolling stock, you'd pick on freight. So someone who's tackling that really difficult job is Ewan Spencer from Siemens, and Ewan is going to talk us through their freight fleet fitment work. So let's hear how that's going. So Ewan, do you want to bring your camera up, please? That's great. And your microphone on as well? Great, that's fantastic. So over to you, Spencer Siemens.
Thanks, Richard. Well, look, a very warm welcome to you all from a rather chilly and overcast Wiltshire. Whilst it might be a little bit less desirable outlook outside, hopefully what I can tell you today is actually quite a positive outlook. My name's Ewan Spencer. I'm Project Director for ETCS on board at Siemens Rail Infrastructure. And what I want to do is just give you a taster, a rundown of what we're doing, how we're doing it, and where we're up to at the moment with this fleet fitment of the ETC, of the freight fleet. Hard enough to say, never mind do. Tufik said a lot, but look, it's worth just reminding ourselves, why are we doing this? Well, fitting ETCS to vehicles isn't an end in its own right. It's just a means to an end, particularly so with the freight vehicles. They more so than any vehicle, I guess, can and do run everywhere on the network, which makes them a very, very critical enabler for the digital railway rollout of ETCS. Not the only enabler, but definitely a very significant one. So let's just make a start with having a look at if the slides change. There we go. Yeah, let's just summarize the scope of what this project's all about. Now, the fact that I can write the entirety, the scope of this project on 2 lines really belies the scale of the challenge that we have. It really is a big job. It's a big undertaking in many ways, but it's something we're pretty positive about. Let's look at that in a little bit more detail. So if we start off with the sheer volume, there's around, give or take, 745 vehicles in the freight fleet at the moment, and we've got to fit all of those. Within those 745 vehicles, there's 20 different classes of vehicle. Now, within those classes is in fact subclasses, and each one of those 20 and the subclasses need a bespoke design for the ETCS installation. So that in its own right is very, very significant. Those vehicles, they didn't all roll off the production line recently. They range from 2 to 50 odd years old, and that brings with it a set of unique challenges. For example, there's information about the vehicles that simply isn't available anymore, and that's information that we might need to produce the designs. The vehicles over their extensive history have gone through big modification programs, and the details as to what any one vehicle its build state might be may not necessarily be known. And I guess the last point to make is that the stakeholder landscape that we have here is significant. We don't have one FOC or even one freight operating company using just one class of vehicle. There's multiple FOCs have access and use of multiple classes. So what we end up with is a lot of people to keep happy. So bear with me, let's see if this changes. Let's take a look at the journey that we've got to take through this. And it starts off really with surveys, vehicle surveys, where we physically go and look at a number of vehicles in each class, a representative set of vehicles from each class, and essentially set about establishing what the art of the possible is in terms of space for fitting this ETCS equipment. And once we've done that, we're in a position to, in essence, document that and produce what we call a concept design, which outlines where we propose to put the equipment on the train. Then we get into preliminary design, maybe a little bit of a misnomer, but preliminary design is actually the detailed installation level design information. So that's things like mechanical designs and calculations and electrical schematics. So the information that it would be quite possible to use to install the system on the train. Final design is really dotting the I's, crossing the T's, picking up any open points from preliminary design, closing them down, and getting that final acceptance from the freight operators to allow us to move forward into the installation. Now, as I said, on the first in class, that's 20 different vehicles. We use that as the opportunity to ensure that those final designs work insofar as physical installation goes, and thrash out any minor issues that there might be. So once we've got a first-in-class vehicle fitted, we then embark upon a test program. Now, to be fair, the test program in reality starts much earlier in the process with lab-based testing, and in fact, the vast majority of the functionality of the system is tested in the lab. But we install it, we do some installation level tests, we do static and slow speed testing in the depot, and then the vehicle will make its way to RIDIC, Network Rail's Railway Innovation and Development Centre, to run on the test track. Then it goes into a period of reliability running. Once that's all completed and we've got vehicle acceptance for the FIC design, we can embark upon the fleet installation. Now, each of those steps is, of course, achieved with and accepted by the freight operators, and it's really key to have that level of engagement so that ultimately we're delivering what is both acceptable and desired by the people that have got to live with this for the future. Now, we talk a lot about the installation design, but the reality is that that's almost just one part of the process that has to be undertaken to get us from a standing start through to installed vehicles. And the installation design focuses on taking a architecture, system architecture, and applying it to the train, but building up that system architecture such that it's compliant with the specification, the standards, and so on and so forth. There's a significant piece of work, and our system engineering team wouldn't thank me for saying it and oversimplifies it, but in essence, we're talking about requirements analysis, working out what do we have to do, what does the system design look like that meets that architecture, and ensuring that it traces back through to the source requirements. Obviously, that has to be done in conjunction with the test team in support of the approvals. And of course, the human factors aspects are significant. We have to design a system that will be usable, that will be acceptable to the drivers and the maintainers. So when we get into fleet, we're starting on the premise that we've been through first in class and the testing and acceptance. And when we get to fleet, what we know is that the system and the system design as applied to the train will work so long as you've installed it correctly. And that's largely what the testing regime becomes once we get into fleet fitment. Get it installed on the train, undertake testing, again, static testing and slow speed testing in the depot. Approvals required for that particular vehicle, update records and so on and so forth, and then get it out into service. So look, it's a pretty significant chunk of work, and as I say, actually looking at trains and putting bits of kit on them is really just one small part of a very big set of activities that have to be undertaken to make this possible. So where are we up to? Well, let's see. There we go. We're actually doing pretty well. We're underway on 16 out of 20 of those classes, and that includes a lot of work around the areas we talked about: surveys, system engineering, HF, installation design, so on and so forth. We've got preliminary design underway on 7 classes, and indeed the class 66 and 67, 2 of the most prevalent classes in the UK, their preliminary designs are substantially complete. Getting to this point, we have dealt with a lot of general issues that affect the whole fleet. So it actually feels like what Tufik mentioned, K2, we certainly feel like we've gotten to the crest of that mountain, and that will soon be on the way back down the other side. And the graphic on the right, it's not really to scale, but what it indicates is that there are classes that take much longer than others, and that's generally the ones that we do at the outset. We learn all the lessons, we build up the core architectures, and then the later classes really roll off the back of the lessons learned and the progress made on those initial classes. Oops. There we go. Well, look, next steps, obviously, there's really only one horse in town at the moment, and that's COVID-19. And I've got to say, I don't think any of them are in the audience to hear this, but I have to say the flexibility and the resilience that my team have shown, they barely broke step as they moved out of normal working in an office and moving to home. It really was quite an exceptional achievement, and I know they're not as a team alone in achieving that. But we've cracked on, we've kept going, we're still making good progress. And whilst the access to the depots was limited for obvious and for good reasons during lockdown, we are engaging very closely with the Fox to establish safe ways in which we can get back in there and keep going with our survey activities without putting any of those critical people who keep the freight moving around the country at any risk. Poor choice of words, but the next thing we also need to do is lock down those final designs, the sign off, get through those preliminary designs into final design, get them rubber stamped, and then we can crack on through to installation. And in support of that, we need to continue our mobilization for the installation and then on into RIDIC testing. Ideally, what we want at every stage is to hit the ground running as we transition, so that the whole process is as slick and seamless as it can possibly be. And of course, in the background, we have to keep that sausage machine churning. We got to keep cracking on with all the other classes ultimately, so as quickly as possible, we can get through those 20 first-in-class stages and get through into fleet fitment. So, you know, it would be hardly breaking news for me to say that you know, a project like this has hurdles that have to be crossed. Of course, it does. We're not in the business of taking on easy jobs, to be honest. And I think, look, this picture here summarizes it beautifully for me. Those vehicles, almost exclusively, not quite, were not designed to have something like ETCS fitted to them. It's a very large modification. It's very disruptive. And you look at the desk here on the left-hand side, and you look at the desk on the right-hand side with an ETCS DMI in the middle. We've got to work out how to get that into that desk environment and the impact that it has on the rest of the train. But you know what? We are finding hurdles, but actually none of them are insurmountable. And I'm absolutely confident that with the continued great support that we're getting from the THOC community, from Network Rail, our client, that we're absolutely, definitely going to get this done very soon and provide that key cornerstone to enabling the digital railway. Thanks very much for your time, and I look forward to hearing some questions towards the end. Richard.
Indeed. Thank you so much, Ewan. I think, you know, respect from everybody involved. We all know what a difficult part of the programme this is. And it's greatly reassuring to hear about the very methodological approach that you're actually applying to it there. So great work, thank you. And look out for text questions, maybe you can answer those, and then we'll have a panel session at the end, as we said. So the person who's got the responsibility to deliver the infrastructure parts of the system is Andy Stringer, Chief Engineer at Siemens in Chippenham. RIA took our Signalling and Telecoms Technical Interest Group there recently, and they really opened the doors and showed us around. Their work is so impressive, and I'm really pleased that we've got their Chief Engineer, Andy Stringer, to tell us all about it. Andy, over to you.
Thanks, Richard. Hopefully you can hear me okay, and hopefully you can all see me okay. Those of you that have seen me present before will know I'm not a big fan of PowerPoint, and I don't tend to present with slides. Today's no exception, so if you think the slides aren't moving, you're watching the right show. I'm not going to talk about the technical detail of the project. I think ETCS, there's a lot of information out about that. You probably don't want to hear about a signalling supplier telling you how well the signalling element of the project is going. What I would like to talk about is the innovation we need to unlock to really make this project a success. And that's not about the technology. The technology for ETCS has worked for a long time. If you want to come to Chippenham and see that working on a test rig in the lab, we can demonstrate the technology is real. We can definitely make this work. But can we deliver it as a successful project in the industry? And really, what I'm asking for here is some real innovation to help us deliver the project, because for me, this is an industry challenge to deliver that project. And really, I think we've all got to follow the lead that Network Rail have given us on this. Network Rail have taken a massive step in their partnering approach for this, really opening up, and it's quite a brave step to do that. And for me, that's a company that can see evidence over human perception, and human perception can be quite dangerous sometimes in the driving the decisions that we make. So seeing that lead from Network Rail, I think we should all follow that, and we need to make this a success. And it's no coincidence that I'm going to repeat a lot of two-fixed messages. We didn't actually coordinate today, so I was quite pleased that actually when I saw his presentation, there's a lot of the same messages in there. We talk about ETCS first deployment on the East Coast Main Line. And first deployment, it's kind of a signal engineer's joke, isn't it? It's the first deployment, because it's probably going to be the fourth deployment of ETCS in the UK, and 5, 6, 7, 8 projects have started off in the past to do this. In fact, the first baseline for ETCS was published in 1996, so we're only 24 years into the technology as a kind of working technology that we can deploy. I think the thing that I want to pick up on, and Tufik nailed the point really well, is this might be the last chance if we don't get it right. We've got a huge advantage in rail. The coefficient of friction advantage that we have, steel on steel over rubber on tarmac, is huge. We can lose that advantage if we can't deliver it efficiently, and if we don't know how to talk about the success and the benefits that it brings. We've really got to think about this, because if we overspend on this one, we don't make this project a success, where will the money go next? We know COVID-19's there. We know the government want to spend a lot of money on infrastructure, but is this where they're going to want to spend it? We really need to make sure that this is a success. We can't, as an industry, hide behind any excuses. We've got to make this one work. But I think, first of all, to do that, we've got to agree what success looks like. And I'm not convinced that as an industry, we've all agreed what success looks like. I thought the Network Rail video shown at the start was absolutely excellent, and it really kind of concisely puts together the building blocks we should be using to talk about what success looks like. I think, though, we need to build on that. We need to put some more tangible benefits behind it, because I think that video could have been made 20 years ago when we were doing TCS on the West Coast Main Line. We could have talked about the improvements in capacity, performance, renewing assets cheaper, a safer railway, and the wider benefits you get from that. We could have talked about all that. We need to make those real now. I have a good friend of mine who's a railway civil engineer, and he's always asking, why are we doing ETCS? Why are we going for this European train capacity system? Train control system, sorry. Because does it give you more capacity? Because as a civil engineer, he knows where capacity comes from, and that's more tracks. How much more capacity are we going to get? And actually, I haven't got an answer for that on the East Coast yet. So we need to get that kind of question. How many more trains an hour are we going to get? If we do get more trains an hour, are we actually going to have enough coaches to run them? Those, for me, are kind of fundamental questions we need to answer. But as well, I think we need to get a wider story straight on that. We talk about the safety benefit. We've got the safest railway in Europe by probably tenfold. If you look at the stats on European performance and on British performance, 13th year just completed without a passenger fatality on the railway. It's very hard to justify investment on what's already the best. And in many of the criteria we measure our current UK railway, it's actually pretty good. We're not often very proud of it, but it is really good. And so we've got to be talking about what goes next. I think frustratingly for me, I was looking on LinkedIn this morning, and there's a classic example. Somebody from the ORR's put about the reasons to go to ETCS, to go to cab signalling rather than conventional line-side signalling. And there's a lot of senior people from the industry in their comments casting doubt on whether it's the right solution. Now, if we can't convince the signal engineers that it's the right thing to do, we're going to really, really struggle to convince the people that are spending the money that it's the right thing to do. So I think the first area of innovation we need to look at is agreeing what those benefits are, so that we're all saying the same message, we're all giving the same message. I think that Network Rail video at the start is a great place to start from. And if we can all just start talking about that, and the 5 pillars that Tufik shared with us about capacity, performance, cost, safety, and the wider benefits, if we can all push those and develop those and communicate strongly and consistently why we're doing it, and let's us all agree that it's the right thing to do, then we've got a chance of convincing everybody else it's the right thing to do. For me, that builds into a really key message that comes out of Network Rail a lot at the moment, called putting the passenger first. Great initiative for me. I like to put my own little spin on it, and I call it, will the passenger notice? And when you've delivered a railway signalling project, I always think it's a useful thing to look back on. All the things that you argued about, the things that you sweated, that you cried about, the real problems, the huge changes that we went through, will the passenger notice? So one thing you can guarantee is they'll notice the disruption. And if you look at any major upgrade, in many cases, the passenger thinks, well, all I did was I was late for work every Monday for 2 years. And afterwards, the performance was what it was before. What's the benefit to me there? I think we really need to focus on what the passenger's seeing differently. And for a lot of the East Coast upgrade, at least initially, when we're doing transitional work to get the existing infrastructure ready to put ETCS on it, they're going to see disruption and possibly not a lot of tangible benefit unless we show them what that benefit is. And probably the thing that we need to really start thinking about is what will they be able to do as passengers that they can't do now? And what can we innovate around that? What could we do with an ETCS driven system that we can't do now? And this isn't a question for the signal engineers. This is the benefit that what can the app developers do? The people in the technology world, what can they do once we give them a digitally enabled railway? It's not for us, it's for what are the little benefits that we can get that we can't currently do now. It's really hard when you think about it to think about what those benefits might be, particularly when you're looking for big numbers. When they upgraded the West Coast Main Line, we didn't use ETCS in the end, although that was the original intention. But we did deliver from Birmingham to London a 50% increase in trains. We went from a half-hourly service to a 20-minute service. It's almost a walk-up service. If you go to Euston or Birmingham International now, it's probably only 15 minutes to wait for the next train. That's a huge benefit, and it's really hard to match that. But we need to think about what we can do. But also, if we spend a little bit more, what other benefits can we really bring about? The third area I'd like to look at is talking about how we deliver the project. And the technology I've spoken about, as I've said, we know the technology. We've got that. We can do it in our sleep. We know it works. We know how to make the technology work. We know how to fit it. The problem with railway signalling projects is always delivery. And how do you deliver it smoothly? And how do you deliver it in a cost-efficient manner? If you look at projects that have overspent, it's very rarely the signalling itself, the signalling technology, the choice of interlocking, or the choice of control system that's caused an overspend or an overrun or the program to go late. It's usually something else that's come up. There's lots of difficulties in delivering a railway project. Not least, we have to keep the existing railway going. And I think there's two key challenges in this area where I really look to industry to help us innovate, and potentially the smaller organisations in the industry that can come and work with Siemens and the other delivery partners to talk about how we do this and how we really we focus down on it. I think the first thing is about access, and it's increasingly hard to get access to the railway. But increasingly, we need access to the railway to install the systems and to test the systems safely. Some of you will have read the RAIB's annual report this year, and it's quite a somber report, and it makes you think because there were 3 workforce fatalities in the last 12 months, and that's a big number. And we're not used to that kind of number of workforce fatalities in the UK, and we have to sit up and take notice of that, and we have to do something about it. The RAIB annual report's pretty clear about what the solution is. We have to stop mixing people and trains. And that's quite easy to say, unless you want to upgrade the southern half of the East Coast Main Line in a cheap and efficient way. But we need to find a way to address that. We also need to think about the non-project costs that we have to incur. When we do a big project like this, there's lots of other things that need upgrading, and they need upgrading to current standards. Take an access point. When you're doing a project like this, it's unthinkable that you would leave an access point that's not fit for purpose. So we have to do that. But actually, access points get more and more expensive to bring them up to what you would call current standards and acceptable standards. The need for good access and safe access gets ever greater. Our ability to deliver that on the project and the ability to do that quickly and without it being disruptive in terms of cost, that's really, really key. Probably the one that's really challenging to me as a signal engineer is thinking about the alterations we have to make to the existing systems, lots of them, as we're delivering the new trackside signalling system. If you were going to deliver an ETCS level 2 system, you wouldn't start with a relay-driven interlocking controlling all that length of railway. You'd want something much more modern that you could just simply overlay. And so we have to get to that much more modern thing that lends itself to applying a digital solution. So during that, we have to have stepping stones to allow us to deliver the signalling system. Each one of those stepping stones comes with its own challenges, because essentially you're trying to breathe new life into an old interlocking. You're trying to enable it to do things that it can't at the moment. And whilst we might replace all the relay element of it, a lot of the trackside system, the signals, the point machines, the cable runs, the cable trough, they're all going to have to stay. but they need bringing up to modern standards. And the cost of that is quite often quite prohibitive, because the cost of that would bring them up to modern standards with an expected life of, well, for a signal base, maybe 50 years, even though that signal might only be there for a matter of months, but we still do it to the same standard. We have a kind of perception that the existing system lives on some kind of grandfather rights, and you can argue how much you believe in grandfather rights for various kinds of safety assurance and safety approvals. But when it comes to the maintainer's safety and the people going out there to access it, the Health and Safety at Work Act's really clear. You've got to be compliant. Just because it was acceptable when it was built doesn't mean it's acceptable now. But to bring something up to that standard and the cost of doing that for something that's going to disappear in 2 years' time, that's a real challenge for us. And in that, we've got to get the maintainers buy-in and the operators buy-in. I'm sure there's maintainers across the network at the moment that feel a little bit shortchanged that their bit of railway with thought ETCS was coming by 2013 or 2017 or whatever the original aspirational dates are. That's not happened, and now they've got maybe 10, 15 years extra to get life out of an asset that wasn't renewed, or that they agreed that they'd carry on maintaining at some additional cost or some inconvenience to them. So I think those two key areas in delivering the project, how do we get that access? How do we make it safe? How do we deal with that challenge of the stepping stone alterations we need to make to the existing system? That's pretty much all I want to say in terms of the first deployment. I think it's really key that we make this as a success as an industry, because we might not get another opportunity. There is no plan B. There's no alternative signalling system sat on the shelf that we can all deploy next year if this one doesn't happen. We've got to make this, because this will generate the next opportunities for everybody in the industry to go deploy a full digital system. So we've got to agree on the positives. We've got to build on ETCS being there and think what the wider benefits are, think how we can innovate around that. We've got to get all our innovation into delivering the day-to-day project as best as we possibly can, as fluidly and as smoothly as we can. And probably my final thought for you, let's hope that this is the project that's remembered as the project that finally used innovation to deliver success. My question for you is, do you want to watch that, or do you want to be part of it? Thank you.
Thank you very much indeed, Andy. And again, loud rounds of applause, and I think a tremendous recognition there of the real challenges, but also the opportunities in this project. They're immense. And we've really got to work together as an industry through the supply chain and the customer working together. And we stand or fall together, particularly in front of the government and in front of the public as well. So thank you very much indeed, Andy. Just remind folks again that if you've got questions you want to pitch into the pot, we're getting quite a lot now, it's spooling up. Go across to your grey dialog box in your screens, probably across on the right, and open up the questions tab and get typing away in those questions. So now we come to our elevator pitches. We've got two today. They're 5 minutes for an SME to share some of the innovative work they're doing in or around this project. I'm really pleased to introduce Emily Kent, Director of One Big Circle, Specialist in Intelligent Video Solutions. So Emily Kent.
Thanks, Richard. Hi, everyone. Yeah, as Richard says, my name's Emily Kent. I'm the co-founder of One Big Circle, Specialist in Intelligent Video. Our background is not in the rail industry, it's in video, and hopefully, hang on, let me click on a screen to get this to take possession. So yeah, we're a Bristol-based SME. We've got a 35 years combined experience in video, but in other industries, previously worked in highways and in sports, and a range of clients, including Costain, BBC, and the MTC. Our hardware and software expertise is all under one roof. So we're one of these really, agile SMEs that want to deliver solutions. So last year we were looking for opportunities where else we could take our capability. And after some market research and analysis and a good look into the rail industry, and that's a bit of a pre-COVID picture there, but from our research, we understood there are multiple challenges, but also we felt that it was a very outward-looking industry looking for innovation. We understood the concept of the digital railway, the challenges that were being faced, and potentially we felt there was something that we could offer here as a solution. So how could video help meet some of these? What we wanted to do was harness the coverage of operational trains. And how is it you can see a spelling mistake the second you check something over and over again? I've seen a spelling mistake, so apologies for that. But what we wanted to do was create a video capture device that could sit on any operational train and capture video from that train, and essentially enable those of you that are at the sharp end of the rail industry to see what your trains can see as they travel around. So those 20,000 miles of track are no longer something that you're sort of blind to, unless you've been able to capture video data from another system that's already in place, from the NMTs, for example. So we wanted a way to accelerate all this process. So we developed our train-borne device, AVA, which is Automated Intelligent Video Review. And that can sit in any operational train and capture video as it travels around the track. And then the key to it is we wanted to transmit that data off the trains instantly, so it was available to those that needed to see it straight away. And as we talked to the industry, understood that people's problems are kind of where the bottlenecks of data were, we started to understand the value there was of getting this data in front of the people that need to see it. And as Nick King mentioned yesterday, you know, sort of data everywhere, but not a drop to drink. How could we get the valuable data into the hands of the people that needed it? So we went to a lot of events, talked to a lot of people in the industry. We may even have spoken to some of you in the audience at various things. But we essentially developed an MVP based on those responses, trialled it at Quinton, and managed to talk ourselves onto the NMT and into a trial with Transport for Wales, and getting our phone device into cabs and enabling people to see that data straight away. Both of those successful trials leading to contracts with Transport for Wales and with Network Rail. And then COVID-19 came along, and the challenges came thick and fast for many of you about not being able to get on the track, not being able to see what you needed to see previously. AVA was fairly mature technology by this time, but it really needs to be deployed much more rapidly. So this is an overview of the system, essentially. AVA technology can sit on board any operational train of any class, going at any speed, and it will transmit that data to the clouds. Over on the left there, you can see a number of routes that have been captured on different dashboards that we've worked with Network Rail, and in particularly Signalling Innovation Group. The data is then transmitted from the cloud and made available through secure individual access. So for people working from home, this was invaluable to be able to get into the data that had just been collected on the rails literally earlier that day, at any time before that. And in response to those, working closely with Network Rail, we rapidly developed a number of tools to be able to annotate that data, mark it up, make measurements on it, get analytics from it, create PDFs. So I'll just show you through a few of our capabilities. So this is a freehand markup tool where you can draw on things that you have just seen on that video, and you can share that with other AVA users. And work with that across teams collaboratively. So you can really work from that single source of truth. You can make measurements on the track as well. So by using the gauge of that railway, we were able to calculate different distances from that track. So again, using footage that's just been collected in the previous days and weeks, you can make measurements on trackside assets. You can do plans for cable measurement, and kind of a multitude of different things. Those measurements can be shared and reviewed, as with the previous annotations as well. Just move to the next slide as well. We've got history review as well. So anytime that AVA's been over the track, you can pause that video and get a history of any moment that the AVA technology has been over that track. You can alternate between different dates, different up and down direction and that sort of thing. And what I'm showing you here is the AVA platform that we have developed and evolved in response to the people that we are working with closely. And that's that, as I say, that's all. And I see Richard's face has popped up, so I'm going to hurry this. These are the download capability as well. So this is what can be shared with your team. So any markups that have been created can not only be seen on the laptop, but downloaded and sent out to on mobile devices. I'm just going to, those will be shared. That's some great feedback from people who we've had in the last couple of weeks. This is what we want to achieve about harnessing the reach of operational trains, collecting that data and enabling you to respond to measures restrictions both before COVID-19 and also significantly now, and helping reduce that boots on the ballast, as has been mentioned by previous speakers. And yeah, this is how we respond rapidly to the industry needs. A big shout out, as I say, to Siddling Innovations Group and for Transport for Wales in taking this innovation in really early stage and also helping to deploy it so that it becomes really fit for purpose. We want to be one of these SMEs that are delivering innovations into the industry, but working really collaboratively so it becomes a really fit for purpose tools. We've had ESRs prevented because of this, critical safety moments raised, hundreds of new users in the last 2 weeks. And I think on the slides that are going to be shared, there's a link that shows you some of the capability. So anyone interested in knowing more about this, the contact details I think are all going to be shared at the end. Thank you.
Yeah, and thank you very much indeed, Emily. And we'll just join you there in a round of applause for David Shipman and the Signalling Innovations Group, who are doing great work. Thank you. Fantastic to see you making progress in the industry. Really, really pleased about that. And hopefully other people today are going to pick up on ideas and they can contact you around this as well. We'll hopefully come back to that in the Q&A. Okay, so our second pitch then, which is Martin Pocock, Development Director of the Oakland Group. Again, just started working in rail, working with data analytics. Martin Pocock. Martin, we've got no sound from you, Martin. You need to re-enable sound, please.
There we go. Sorry, schoolboy error. So good afternoon. I really appreciate you giving me 5 minutes for this elevator pitch. What I'm going to do, I'm going to talk through Oakland's intelligent forecasting system, where we combine real-world data and modern analytics. Now, I'm here today because I think it's relevant to RIA members. We're successfully using this amongst others, Network Rail. And typically, we highlight hundreds of millions of pounds of project forecast errors months before they are actually realised. At the end of the elevator pitch, you'll have heard a little of the system's capabilities, and it may turn out that it's not for you, and that's fine. Not everyone has these sort of problems or needs this sort of solution. However, it does sound relevant, or you have questions. There's a Q&A session later. I'll also provide contact details. But first, a little about Oakland. So we are an independent SME. We've got a long history in operational excellence and huge expertise in data analytics. And we are, yes, relatively new to the rail industry. We've only been working in the rail industry for somewhere between 5 and 10 years. Now, we initially developed this system based on experience of working with our clients. We're now collaborating with Warwick University to extend this platform even further. So why do we do this? What problem are we solving? Well, we kept hearing the same comments from many clients. We have lots of data, but little insight, or rather little foresight. They say we need a better way of understanding which of our projects within a large program need support. And they ask how we can generate more value from the data that they already collect. For example, we see projects within a big program, and in a particular project it's got lots of milestones. We see a milestone slip, maybe by 9 months, and it's identified by the project manager in the program plan, but there is no corresponding slip to the overall project outcome, and so the organization is unaware of what's going on. And you think, well, okay, maybe in that month when that happened there's a lot going on, and so you look at the next project forecast, and still there is no mention of this slip. And you go forward through the data, and many months, maybe 6 months or later, you suddenly see that the whole project lurches to the right by about that, say, 9 months of the original milestone slip. So that was half a year or more where the organization didn't know that this was coming, didn't know, wasn't able to compensate for it. Now, as you know, infrastructure projects, rail projects are complex. Now, I'm not having a go at project managers. Their job is already difficult enough. What we provide is a solution that allows distressed projects to be identified so that action and support can be given, stakeholders can be informed, and a better outcome can be delivered. And it allows more accurate forecast of time or of cost or almost any KPI to be achieved. As this intelligent forecasting system integrates all your data sources into the cloud, where we perform clever machine learning analytics. We can travel in time through your data. We can find those unreported milestone slips. We can identify all the other telltale indicators of impending project changes. As clever analysis is all very well, but it will have little impact if it's not effectively integrated within your business. And so we offer the combination of analysis and front-end reporting and that alignment with business reporting process. So here's an example of the sort of thing that can be achieved. The big blob up on the right-hand side there shows that 9 months ahead, the system's impact forecasts are 80% more accurate than the project managers. On the left-hand side is the macro view. A better forecast of how much as an organization you're likely to spend. And then in the middle and the right are actionable insights at project manager or program manager level, that will enable people to go in and support and produce better outcomes for those projects. Now, doing this work, we find a whole bunch of other stuff that's quite interesting, as the TV show would say. Projects that should be closed that aren't, risk that isn't properly apportioned, and so on. So thank you very much for your time, for letting me give you a quick overview of how this intelligent forecasting platform helps. I appreciate it might not be for everyone, but if you do have these sort of problems or asking yourself these sort of questions, well, here you go. Here are my contact details. Thanks, Richard.
Thank you, Martin. Thank you very much indeed. Great. So we're going to move on to our Q&A as a panel now. So speakers, if you can all join me again, bring your cameras up, please, and your mics. And I've really pulled out 4 themes, I think, from the questions. They're quite disparate, but the first one to bring together is that one of the things we've absolutely got to do in this project is work together to communicate to the government and to the public. So being clear about the benefits, the thinking is there. How are we going to work together to develop this and roll it out? So Tufik, would you like to give us your take on that, please?
On the benefits case, did you say?
Yes, yeah. How are we going to pull together? And you've started thinking off, and Andy's backing that up as well. How are we going to work together to develop that and roll that out as a campaign? You said something we can all get behind. That's got to be communicated. How's that going to happen, do we think?
So I think off the back of what we've done with East Coast for the last 2 years, stakeholders really do get this. And the whole point of that film and the minute in the middle was to really explain systemically what's different about the system. The fact you're no longer constrained by the infrastructure signals and the continuous communication with the train. It's a game changer for how performance can be managed. So we need to just amplify that, make it easy. The reality is, if I'm government and I have options of where I put my investment to mobilize the economy, big, scary, complex, integrated, jam in 3 decades time programs are difficult. So the big challenge for us now in the next year, 18 months, is to do concrete things. And I can't stress it enough. I was thinking about it as the other conversations were going on, is that, and I don't want to scare people or sound too alarmist. In the next year to 2 years, if we do not make concrete steps out of the opportunity that's been created that makes people go, wow, okay, yeah, we really see that now. We can see how that's been implemented better. We can see the opportunities have emerged more clearly because of the change program elements. We can see the cost improvements of the technology potential and so on. If it's just another story of difficult projects, complex projects, yeah, it's kind of still too expensive. Yeah, in 2034, when the last bit's done, that's when you see all the benefits can materialize. It'll be finished in 2 years.
Yeah, I think you absolutely, I'm certainly behind you with that, and I'm sure everybody listening is as well. We've got to convince the industry first to get behind it and follow on from there. So perhaps for Andy, and maybe this will ping back to Tufik as well, but one of the key stakeholders here is the public, and the way the public interface often with the railway and particularly on East Coast Main Line South, is level crossings. What do we think the impact on level crossings is of moving to ETCS? A train's going to be so frequent that we're not even going to be able to get across a level crossing. What's the impact on safety? What are the other design options? Andy?
Yeah, I think there's a real challenge on that, particularly if we can get to bits of the East Coast where we do improve capacity. There's actually a risk that not necessarily the crossings close for so long, but people will take matters into their own hands, and pedestrians in particular will start jumping. They'll start working out how long they've got before, when they see the barriers come down, and the locals will know, and I think that's a real risk. I think probably level crossings need a really good look at, because they're exactly the kind of thing that could derail this project. And level crossings are a problem. It's not an ETCS problem. Level crossings are a problem wherever you go in the country. You know, the least safe bit of the railway. They're the safest bit of the road network, but the least safe bit of the railway. We as an industry need to get on top of that, and probably we might have to face some big questions in terms of, let's let the civil engineers solve it, because signal engineers can't. And if I was to say to you now, let's put in a level crossing between City Thameslink and Farringdon, you'd think I was crackers, and that's where we're at.
Absolutely. Tufik, did you want to add to that?
Yeah, I mean, most of this are legacy issues, aren't they? So it's politically difficult. It's difficult for communities. One thing I'd say is that, you know, this program particularly isn't driving for more capacity. So fundamentally, it's renewals oriented to improve how you run the railway. It is a better way to signal and control and manage performance of the railway. What you get out of that is up for debate. Now, if the demand is there, there will be different service patterns, maybe more service patterns. One thing we've seen in the modeling that we've done with LNER, for example, on the program, is that because you have more superior train protection, and because the level crossing doesn't have to close so much earlier, because your protection point for the train is much further at a fixed location that was designed in 1983 or whenever it was designed, you might be able to keep a level crossing open a bit longer, maybe. But that's something that needs to come out in the design process.
It's certainly a key point of interaction for the public with the railway, and keeping them on side, you know, means not making their life absolutely unbearable. So it's a design constraint. Okay, second theme I picked up then, and I think we all agree on, is we've got to deliver value for money, and a key part of that is avoiding overspend. Ewan, you're very, very confident about your program, and yet we all know that it's a really difficult program. Do you think, what have you got in mind for making sure you don't run into overspend later in the project or time running over? And do you think Martin's approach holds some interest for you?
Yeah, look, this always comes down to a little bit of realism and a little bit of pragmatism about the nature of the challenges that we have to overcome as part of the rail industry. And you know, we always strive to make the best of whatever comes our way. And you know, absolutely, it's really fundamentally about openness, honestness, and commitment, and it's with those sort of three elements working together that we can find a way through this. Now, you know, just to reiterate the point, fitting ETCS isn't a means, isn't something you do for its own benefit. It's a means to an end. It's to let Tufik run his railway with ETCS level 2. So it's really important that we don't fall into the trap of looking at these things in isolation, that we look at them as part of the big picture. And if we've got to deal with challenges, then we've got to deal with challenges, and we deal with them as expeditiously as we can. Absolutely, there's technology out there to help us operate our projects in the best way possible. And you know, we're always open to looking at those opportunities, but fundamentally underlying it is we're dealing with a lot of the unknown here. Every step we take forward presents a new view of the path that we have to negotiate. So yeah, I think we just need to be realistic about the scale of the challenges that we take on in the rail industry, and accept that sometimes things don't quite go to plan, but that doesn't mean to say we back down. We crack on and we get it done eventually.
Okay, thank you. There's a lot of determination there, Ewan. Emily, I wanted to ask you, we're actually getting some really positive feedback about AR/VR from the audience. So that was unsolicited, so well done.
That's good, thank you.
Andy was throwing out the challenge to the supply chain and to SMEs, which we absolutely respect. That's a great position, and you know, it's one of the reasons we invited Andy along, particularly. But Emily, how do we help you? You know, Andy's saying he wants to talk. You've got ideas to share. How do we broker those two things together? What's practical in terms of help for you, Emily?
Yeah, I think I mentioned in answering a question earlier as well, the being able to have those conversations very early on in the life cycle here of the technology that we're creating means you get synergy between what the requirements are and also what the technology can bring. So conduits to those conversations are really key, and obviously without being able to get together, having events and things like that where you can make those engagements and have that conversation, I think a real clarity about what is being looked for to meet the challenges, which can be matched with these evolving technologies, is really key. And there are multiple routes to it, but maybe even further clarity on that and a greater kind of call to arms, especially in the current circumstances that we're all going through, that greater call to arms as what is out there and what we're looking for. And I know industry maybe feel they might have done that, but it can be done more. You can never have got that message out enough. So I think anything more could be done to emphasize that, as much as you feel like you might have said it till you're blue in the face. It just needs to be done that little bit more, so which encourages confidence from the SMEs to then deliver those ideas. And there has been some great stuff that we've seen to enable that so far, but just do it more.
Thank you, Emily. In a modest way, that's what we're trying to do with these Unlocking Innovation events, is to introduce people, have a show and tell, get people to be honest about the challenges and the solutions they have. The fourth big theme I picked up is that, okay, this is a new scheme, a new infrastructure scheme, if you like, but what we've got to do is bring the operational railway along with us. One of our questioners, Tom Ross of SPI, says he's seen a system in Norway which is about training of drivers and signallers together, which is almost a shock. I don't know if that's something we've thought of before. What have you picked up on your tours, Tufik, that represents a good way of bringing those operational users along with us?
For me, simulation is fundamental. When you're delivering an operationally based system, so you've got all these different people who are parts of this system, and they do stuff every day. They're trained, they're retrained, they do it by intuition. If you're going to fundamentally change elements of that, you can't just put them on a 2-day training project, and we've captured some requirements 7 years ago that's written in a document that's so big that no one can remember how it's organized, and we expect that to just pop out at the end as a perfectly working system. And in software, this is completely established. There's user experience design, people-centric. There's a whole methodology around how you do that. In operational engineering, it's not so much so. So I've seen at NATS, for example, they have this pod area where all their new technologies played with by the users. So the users here are the users of the system, not the users of the railway, not the passenger and the freight user. And that is built into the design process. So, for the program, it's the first of our critical success factors. They're involved in the design process. We have a user design working group. So Paul Boyle and colleagues from the operational community are working with Siemens and design engineers. That's the first major point, helping them understand how the railway works today, exposing all the opportunities, feeding back solutions, taking imagination as far as it can go, but then that will only go so far, and then you've got to let them play with it. And I love the idea of having signallers and drivers simulate the railway together, because that brings the reality much closer to what you can do without that.
Well, the good news is, as part of our innovation day on Thursday, we're going to look at modelling and simulation as well. Sorry, there was some other input there. Was that Martin?
Sandy. I think simulation is absolutely key, and simulation can save a fortune if you spend on it. Quite often with the simulators, we've got test rigs where we are, and they've got a little simulator on them for the driver's position, and it's a little bit like driving a train, but it's not like driving a train. We need to make those simulators really like driving a train. and then you can really use that for training. If you go to the aviation industry, that's exactly what they've done. And when you're in the cockpit of the simulator, it's not that much different to being in the actual aeroplane. I think there's a step to come before that as well, and we need to get back to re-educating our people about what the railway is currently like today. And that means putting signal engineers back in the cabs of trains and signal engineers back into signalling centres so they can see today what happens, because we know what we're going to deliver, we just don't know what's there today, so we can't assess that change. And if we can get the people who are doing the delivery of the new systems to understand what it's really like on the front line, what a freight train's like at 3 o'clock in the morning in the rain, that's when we'll see the benefit.
Yeah, absolutely.
And Richard, could I just add?
Sorry, Emily.
Sorry, Richard, I'll just say, I mean, we're talking about integrated process here. A kind of a feature that happened with Ava that wasn't expected is actually that footage is being used for driver training remotely. So if you've got one system collecting up-to-date data that could be integrated into a simulation system, then you're looking at a joined-up approach that helps deliver on all those targets. So the increasing conversations that knit these things together, is the more it benefits the industry across a kind of multiple applications.
Yeah, absolutely. You know, developing lone simulators seemed like a good idea a few years ago, but now it's actually only part of the picture, isn't it? We'll be covering simulation and modelling much more again on Thursday with Professor Clive Roberts from Birmingham University. So I hope that's been useful for our delegates in bringing everyone up to speed on where the first rollout projects are and where they're going next. Tomorrow we'll be going on to look at the long-term view, where there's much work going on to assure the industry that this isn't just a one-off project, as our speakers have talked about several times now. It's actually a proper 20-year program. So just remains to say thank you once again to our speakers, to Tufik, Ewan, Andy, Emily, and Martin. Thank you very much. Thanks to our delegates for turning in, and a huge thank you to all my colleagues at RIA who've worked so hard on pulling this together and working away in the background together today to help us put it on. So thanks to everybody involved, and we'll see you at 2 o'clock tomorrow. Thanks very much.
Thanks, Richard.